Alright, so section P4 focuses on polynomials. So we've been seemingly building up to this point. So polynomial is either a single term or the sum or difference of a monomial. So a monomial is a single term. Each monomial has a degree, which is the sum of the exponents of its variables. So in terms of a degree, if you have 3x squared, then the degree is equal to 2. Biggest exponent is 2. If you have 1/2 x squared y squared, then the degree will be equal to 4. y4, you're adding up the exponents. 2 plus 2 is 4. So the degree of the whole polynomial is the degree of the term that has the largest sum of the exponents. Sounds a little convoluted, but we'll get into that shortly. Now, in terms of determining whether something is a polynomial, in order for something to be a polynomial, it has to fit 3 criteria. It has to fit 3 criteria. 1, cannot have any roots of variables. So that means square root of x is disqualifies. So if you have the square root of x, it's automatically disqualified. Cannot have any fractional or negative exponents. So if you have x to the 1/2 power or x to negative 3 power, disqualified. Cannot have no variables in the denominators of any fraction. So obviously you can tell just from that bullet point that I'm a math teacher and not an English teacher, because I would have gotten in trouble for the double negative. But no variables in the denominator of the fraction. So 1/x or a over b, things of that nature, disqualified. So the first thing we can do with a, b, c, and d is simply tell whether or not it's a polynomial. So in the case of part A, there's no square roots, so that's good. There's no exponents that are fractions or negatives, so that's good. And there's no variables in a fraction, so that's good. So the answer for this would be yes, it's a polynomial. So if it's a polynomial, then we can state the degree. So the degree is simply the biggest set of exponents. So this 16 has a degree of 0. 8x to the third is a degree of 3. Negative 4x to the fourth is a degree of 4. 2x to the fifth is a degree of 5. So the degree is 5. So if it's a polynomial, then you give the degree. If it's not a polynomial, you do not have to give the degree. So, any questions on that? Nod your head, give me a thumbs up if you're okay, good. That it gives me a little bit of reassurance that you all can still hear me. Still a little leery with I'm working on my computer and stuff. But so part B. 1/4 x to the fourth y to the third minus 8x to the fifth. So there's no roots, there's no exponents that are fractions or negative, there's no variables in the denominator. So this is yes, it is a polynomial. So now we look for the degree. So this first term, the degree is 4, 3, so that's 7. And the degree here is 5. So So the degree for this polynomial, 7. So your degree would be 7. So again, if it's a polynomial, you give the degree. If it's not a polynomial, then you just put no and you keep it moving. Part C, square root of x. Look, we don't have to look at anything else. Square root of x, that's a root. Answer is no. Part D, x to the negative third power, negative exponent. Don't have to look any further. Answer is no. So, purpose of this exercise is very simple. In order to add, subtract, multiply, divide polynomials, it has to actually be a polynomial. There's no sense in doing it if it doesn't even satisfy being a polynomial. So, before we move on, any questions floating out there? Questions, comments, things you need clarity with? So, remember for degree, you're adding up all the exponents that the term had. So, for part B, you have an exponent of 4 and an exponent of 3. You add those up, you get 7. So when you're looking for a degree, the variables do not have to be the same. Does that answer your question? Okay. So yeah, for a degree, the variables do not have to be the same. All right. Let's get to doing some algebra with it. We'll start with adding and subtracting. So polynomials are normally put in parentheses just to separate one from the other. So in the case of example A, 6x squared minus 7x plus 8 plus negative 4x squared plus 9x minus 5. So in this case, we're adding. So when you're adding, the parentheses mean nothing. When you're adding, the parentheses mean nothing. So you can go right ahead and just combine like terms. So you have 6x squared and negative 4x squared. Put those two together. 6x squared, negative 4x squared, 2x squared. Negative 7x plus 9x gives you positive 2x. 8 and negative 5, positive 3. And that's it. That's your final answer. So when you're adding, you're just combining like terms. The parentheses mean nothing. Now, when you're subtracting, when there's subtraction in the middle, the first polynomial comes down. So you keep the first polynomial. You're going to take the negative and you're going to distribute the negative into the second parentheses. So that gives you negative 2x squared minus 3x plus 1. So keep the first parentheses, distribute the negative. Now you combine like terms. 4x squared minus 2x squared, 2x squared. Negative 5x minus 3x, negative 8x. 6 plus 1, 7. So rule of thumb there. Keep, distribute that negative, Any questions with parts A or B? Any questions with A or B? We all good there? All good here? All right, looks like we're all good. So let's move on to doing multiplying. Let's move on to multiplying. So multiplying exists in a whole bunch of ways. Most of these ways involve distributive property. So problem 1, 3x times 2x squared minus 4x plus 6, basic distributive property problem. So 3x times 2x gives you 6x to the third power. So remember from yesterday when we did properties of exponents, if the exponents are the same, if the bases are the same, keep the base, add the exponents. 6x to the third minus 12x squared, and then plus 18x. So basic distributive property. Basic distributive property. So moving on to the right, 4x plus 3 times 2x minus 1. So that's a FOIL problem. So I'm assuming most of you have probably heard FOIL before, distributive property with FOIL. 4x times 2x, 8x squared. 4x times negative 1, negative 4x. 3 times 2x, positive 6x, and then minus 3. And then combine your like terms up, get x squared plus 2x minus 3. Again, if something's not clicking or if I'm going a tad bit too fast, just let me know so I can slow down a skosh. If you're good, you're good. If you finished the problem already, then go ahead and you're not hurting my feelings. Same thing with 3n minus 2 and 3n plus 2. So this is a FOIL problem as well. 3n times 3n, 9n squared. 3n times 2, 6n. Negative 2 times 3n, negative 6n, and then minus 4. Then you combine your like terms up, 9n squared minus 4. So this fourth example, y plus 7 raised to the third power. Y plus 7 raised to the third power. So think about what I said we can't do yesterday. So yesterday, we can't do y to the third plus 7 to the third. That's not going to happen. So what should I do to that problem? What should I do first? Anybody got any guesses? All right, go for it. Okay, well, we can roll what you just said. First, write it out 3 times. We're going to multiply 2 of them at a time. So take the first 2, multiply them out. So that's y squared plus 7y plus 7y plus 49. So y squared plus 14y plus 49. Now, I put it back in parentheses because I now have to take this answer and multiply it times the third part. So that's the reason why I put this back in parentheses, because we're multiplying it times y plus 7. So, y squared times y is y to the third. Y squared times 7 is 7y squared. So I'll do it in different colors just to highlight the parts. 14y times y, 14y squared. 14y times 7 is 98y. Color. 49 times y, 49y. 49 times 7, 343. So now all that's left is to combine the like terms. So we've got y to the third power plus 21y squared. 98 and 49 is 147. 147y plus 343. My adding was off. Let me know. A little senile in my old age. So let me know if I was off. So, any questions with the 4 problems at the top? Y'all good? Yeah, head nod, thumbs up. Let me know that we're straight. If you're Mackenzie, you're nodding your head. What's wrong? You okay? Okay. That's right. Correct. So the third one, so you really only want to multiply things 2 at a time. So since we didn't touch the third one, we just brought it down so that we can deal with it when we finish. So, okay. Now in the future, don't feel that you have to wait until the very end. If you get stuck, interrupt me with something. If we was in the classroom, I would have told you to throw a marker or pencil at me or something and tell me to stop. I don't want you to, let's see, if it's something not clicking, let me know. But you did good, so I'm happy with that. No, thank you. Any other questions before we go on to the next one? Alright, seeing none, hearing none, let's keep going. So, again, this is more practice of multiplying polynomials. N squared plus 4n minus 6 times n plus 2. So, n squared times n to the third. N squared times 2 2n squared. Move on to the next one. 4n times n, 4n squared. 4n times 2 plus 8n. Negative 6 times positive, negative 6 times n, negative 6n. And then negative 6 times positive 2, negative 12. So this is the same, so all I did was just write each part underneath each other. So it's the same type of setup. Now all we're doing is combining like terms. So the like terms are underneath each other. And then the third, so 6n squared plus 2n minus 12. That's that, problem's over. All right, now let's do this one and then we'll tackle the word problem at the bottom. X plus 2y times 3x squared plus 2x minus 1. So here we have two different variables. That's fine, we can still work with it. Still do it the same way. X times 3x squared will give you 3x to the third power. X times 2x, 2x squared. X times negative 1, negative x. So we've taken care of everything associated with the x. Now we're going to multiply with the 2y. 2y times 3x squared plus 6x squared y. You have two different variables, so there's not really much you can do. So don't force it. 2y times 2x, 4xy. 2y times negative 1, negative 2y. So we finished distributing. But notice that none of these are like terms. There's no like terms up there. So it's your answer. That's all you can do. There are no like terms. Don't force it to work. There's nothing up there that can be combined, so don't force it. So, any other questions before we tackle the word problem at the bottom? That's our last example that we'll work with today. You all good over there? Kenzie, you straight? Okay. Alright, so let's tackle this word problem. The U.S. Department of Transportation limits the time a truck driver can work between periods of rest to 10 hours. For the first part of his shift, Tom drives at a speed of 60 miles per hour, and for the second part of the shift, he drives at a speed of 70 miles per hour. Write a polynomial to represent the distance driven. So, main thing to keep in mind here, we're working with distance. So distance is equal to your rate times your time. Distance is equal to rate times time. So he's working 2 shifts. First part of his shift, he's going 60 miles per hour. Second part of his shift, he's going 70 miles per hour. So you had 60 times something plus 70 times something. So there's your rates. There's your rates. Now we got to deal with the time. So now we got to deal with the times. So your first shift, we don't know how long his first shift was. So if we don't know how long something is, in algebra, we give it a variable. X. If you want to use t, that's okay. Now, for the second shift, they told us that they can only work 10 hours. They can only work 10 hours. So think of this logically. If I worked for 3 hours on the first shift, that means I have to work the other 7 on the second shift. If I work 4 hours on first shift, then I got to work 6 hours second shift. Either way it goes, this has to add up to 10. So if I work X hours on first shift, then I have to work 10 minus X hours on the second shift. So let me pause for a second and ask anyone have any questions about how we got 10 minus X? All right. So for first shift, your time was X. Your second shift, your time was 10 minus X. So we have our polynomial, we just need to simplify it. Now we just have to simplify. So 60 times X, 60X. 70 gets distributed. 700 minus 70X. So this gives you, so your distance is 700 minus 10X. And that's it, problem's over. Not a hard problem, but you had to take apart what the question is asking. Any questions on that word problem before we move to closing up shop? Again, remember this video and the notes handout will get uploaded to Google Classroom, so you'll have both.